Hello everyone, welcome back to my channel. My name is Sai Kiran. Guys, today is day one in our Terraform, which is part of our DevSecOps series only. First, we'll try to understand. Let's not jump directly on the Terraform, guys. First, we'll try to understand what were the cloud native tools actually. Let me open my notepad. See, there is something called cloud native tools. What were exactly these cloud native tools? For example, AWS does have something called CloudFormation templates. Okay, with the help of this CloudFormation templates, we can also automate the infrastructure. But what were the disadvantages we do have to move on to the Terraform? We'll discuss that. Okay, and other thing, there is something called Azure. In Azure, we do have something called ARM templates here, right? And in GCP also, we do have something called Deployment Manager. So for now, let's try to understand what exactly is cloud formation templates and ARM templates and what were the disadvantages here in this cloud native tools comparing to the Terraform. Again, guys, this will be an interview question. They are going to ask you a straight question why you have moved from using cloud native tools to the Terraform. So you can mention all these disadvantages to the interviewer. See, the very first disadvantage is either it could be a JSON file or it could be a YAML file. Either JSON or YAML, you needs to be dumped all the configuration in the same file itself only. For example, I'll write here either JSON or YAML. All the configurations should be dumped in the same file itself only. This is the very first disadvantages. The problem here is, see, if your infrastructure is very huge or if your environment is very big, in such cases it will not work, guys, because in one file we are dumping everything in the sense like VPC, security groups, S3, ACM, route 53, whatever is there, we are dumping each and every configuration in the one single file. In future, the build might gets failed due to some indentation errors or wrong function calling errors. End of the day, the debugging will also be become very tough if you found issues. So this is one of the disadvantages in the cloud native tools comparatively to the Terraform. And the second disadvantage is learning JSON or YAML is bit complex. Learning JSON or YAML was bit complex. At least this JSON file, at least this YAML file is user readable itself only. But when it comes to the JSON file, it doesn't looks like an user readable language, guys. It's quite different again. It's quite complex to read this JSON files and then YAML files, not manifest files. And the third thing here is importing of resources complex in AWS, and this option was not there in Azure itself. Okay, the word importing means even if you're not understanding, it's totally fine. When working on Terraform, we are going to work on something called Terraform import. Then you will be understanding this line. That advantage is not there in our cloud native tools, but in Terraform we do have that. Cloud formation templates will be working within AWS itself only, and ARM templates will be working within Azure itself only. Right? Terraform is not like that, guys. Terraform, regardless of any cloud you're trying to deploy infrastructure with the Terraform, the only first thing what you need to do is you are supposed to call the provider block first, because in the provider block you are going to tell Terraform go and deploy my infrastructure in AWS or Azure or GCP or Alibaba, Oracle, whatever it is. And the next disadvantage is the very important, which is modules concept was not there in AWS or Azure, but modules concept was there in Terraform, which is really helpful. You will be learning that slowly. You don't need to write the code again and again. You can implement some workspaces, and along with the workspaces, you can work on modules where you can deploy the infrastructure with the help of modules in multiple environments. And also, workspace option was also not there in workspace option was not available in AWS or Azure. This is also one of the major advantages, major disadvantages in cloud native tools. And what was the next one? Performing dry checks, guys. Recently, I've seen they have given AWS has given some small update, which is copied from the Terraform, I believe. So they are also giving the dry checks, but I haven't seen the same in ARM templates actually. Okay, as I said before, workspace concept was also not there in the cloud native tools. These are the major disadvantages comparing to the Terraform, guys. So this is the reason why we are going to use Terraform instead of cloud native tools itself. Okay, actually Terraform was owned by HashiCorp actually. HashiCorp also does have some other tools along with the Terraform. Terraform is mainly used for infrastructure automation, and also they do have something called Packer, guys. Packer, if you remember in my AWS session, we have discussed this, and also in the DevSecOps series, we are going to discuss about Packer. So Packer is mainly used for image automation, and there is another tool which is Consul. This is something like a cluster, and also I can say service discovery, and also we do have something called vault. We know this already. Vault, which is mainly used for password, and also we do have something, a tool called Nomad. I honestly didn't worked on this and I don't even know for what it is, so you guys just google about this HashiCorp tool called Nomad. So these are the tools owned by HashiCorp actually, right? I hope you understand, guys. If anyone haven't seen my day 2 git video, not the day 2 DevSecOps video, day 2 git video, there I have explained how to install Git, how to install Terraform, and everything in that video. So please do watch that video and then come back here, because we are not going to talk about any kind of installations here, right? So this is today is quite a big topic. We are going to cover so many things, so we'll go step by step slowly. So please do watch the Git day 2 video and know how to install the Git, how to install Terraform, and then come back to this video. Got it? Let me take you back to the console, guys. Let's start with creating one folder here. Guys, if anyone didn't watch my Git day 2 or day 1 session, please watch that session, because there I have showed how to install Git, how to install Terraform binaries in your Windows system, and also before that you are also supposed to install AWS CLI in your Windows if you are practicing from the local machine. Okay, let's create one file called testing-1 and double click, right click, and then open in terminal, and just simply enter code dot. That's it. So the very first thing what we'll do is we are going to create one file called main.tf, guys. We supposed to tell Terraform to which cloud we are going to deploy, either if it is AWS or Azure or GCP or any other cloud. So let's create one file called main.tf. So how we can able to tell Terraform? There is something called provider block. So I'm not going to write anything from here. I'm going to simply use Google sources. Just type AWS Terraform provider, enter. Go through the documentation, guys. Again I'm saying, make a habit of reading the documentation. The very good thing about the Terraform is each and everything you are going to get from the documentation itself only. See, provider blocks, required provider blocks is not required for us, because I'll tell you in which use case we are going to use that. For example, in real time we'll be having multiple environments, like the namings is quite different, depends upon the organization, QA, dev, and then pre-prod or something. So each and every environment we are going to install multiple tools, guys, right? In that particular environment, maybe the Terraform 5.x or Terraform 4.x is compatible. In such case, you are going to force Terraform to use only particular version itself only by using the required providers. So for now we'll be proceeding with the basic one, which is provider block. Come back here and then paste it. save it. So provider AWS region equal to US-East-1, right? This is provider block and this is the cloud which what we are using, and whatever is there, remember guys, whatever is there between these curly braces, those were actually called as arguments, right? And again, if we come back to the documentation, if you scroll down, this is very very important guys, whatever is there. If you scroll down completely, see, this argument reference were really really important. You can find everything here. See, optional, optional, optional. If it should be a mandatory also, you can able to see mandatory here, right? So make sure that you are going through each and every arguments here so that you will be understanding how to write the Terraform file easily using the documentation. So let's come back here. So once after creating the provider block, what we're supposed to do, we are going to create one VPC. Again, remember, regardless of any cloud, if you are trying to deploy any service, either if it is VPC or security group or IAM or S3, you are going to call it with the resource block itself only. So you are going to call it with the resource block. Come back here again to the documentation, AWS VPC Terraform, simple, and just enter. Just copy this, I mean select that, and then simply copy the resource block here, which is going to deploy the VPC actually. Just copy this, come back here, and I'm going to paste it simply. See, I don't want this instance tenancy. Instead, I want something called DNS host. See, if you still do not understand how can I able to track the DNS host, you can go to the management console, which is our AWS. Just open VPC. You can also follow these steps guys. This is the reason why I ask you to learn at least one cloud first before coming to this DevSecOps series, so that you'll be understanding the flow, at least what to create and what not to create. See, now I'm going to create VPC, and then again I'm going to create subnets, and then route tables, and then internet gateway, and then at last I'm going to create security groups. So this is the actual flow. If you do not know any kind of cloud, then you will not be understanding anything. So under VPCs, again I want something called, if I go to the VPC settings, see, enable DNS host names. I want this actually. So how can I check that? Just now I told you there is something called argument references here. I'll just give Control F and just give DNS underscore enter. See, enable DNS host name. Just copy this, come back to your VPC block and then paste it. Instead of hyphen equals to string, you have to pass, mention it as true, save it. So once you click Ctrl S, it's going to take care of the indentation guys. You are supposed to install one Terraform plugin here from the extensions. Got it? So cider block 10.0.0/16, and then enable DNS hostname true. I don't want my VPC name as main guys. I want my VPC name as VPC hyphen Terraform. Here I'm going to tell you something again. I'll just comment this out, save it. You might be asking a question, Sai, what is the point of giving the VPC name here? See, resource block from where? AWS. Which service? VPC service. Under VPC service, what was my VPC name? My VPC name is VPC hyphen Terraform. Let's give capital T, save it. And again, I am passing the same name here under the tags, VPC hyphen Terraform. So whatever name you are passing here, that name is dedicated to this resource block guys. Whatever name you're passing under the tags, the name is going to tag it to your VPC resource, right? For example, I'll tell you in a more detailed way the reason why we mention VPC hyphen Terraform here. Just copy this, come down, I'll paste it three times. I want total three VPCs. In future or in real time, we are going to use count functions and then we are going to automate this. But just I'm telling the use case of this VPC hyphen Terraform name. For example, I want three VPCs, one, two, and then three. If I try to deploy this, Terraform is going to throw an error stating that, see, Saikiran, we do found some duplicates and duplicates will not be allowed. Correct, right? See, the name VPC-Terraform, Terraform, Terraform. All three were duplicates itself only. In such case, what can I do using with this names is simply one and then two. See, there were no duplicates now. So this is the actual use case of this name actually, right? I'll just remove, save it, and then uncomment this, save it. So tag also I'm going to give the same name as tag itself only, main, and then paste it. Done. VPC is done, guys. What's next? So VPC has been done. What we are going to create now? We are going to create internet gateway, right? Provider we have created, VPC we have created. Now let's go back here and then again internet gateway, enter. It's going to give you the basic stuff. Yeah, here it is. Just copy this, come back here again, enter, and then paste it. So what was my internet gateway name? I don't want to leave it as it is, IZW hyphen, I'm going to give Terra and then save it. So to which VPC ID you wanted to attach this internet gateway? I wanted to attach this to my VPC hyphen Terraform. Save it. I didn't copy it, I think. Dot ID will also be there here and then save it. Let's go back and check. I copied it well. Just copy and paste it again. Control V. Okay, now I got it. So VPC, this is my VPC name. Copy. Instead of main, I'll just paste my VPC ID here. Instead of GW, I'll give IZW hyphen Terraform. Save it, and I'm going to give the same name for my tags also, guys. Just paste it. So okay, we have created provider block, we have created VPC, and then we have also created AWS Internet Gateway, right? What's next? Now we are going to create something called subnet, guys. So let's go back to the documentation again. You can still enter here, but just to show you, I'm just entering directly here. Subnet, Terraform, and then AWS. Open it. Scroll down. See, this is the basic thing. Just copy it. Come back here and then paste it. What was the subnet name? My subnet name was public subnet hyphen Terraform. Give the T as capital, and then I'll copy the same here and then paste it on the tags also. Control S. So to which VPC ID you wanted to attach the subnets? I wanted to attach it to my VPC, and my VPC name is VPC hyphen Terraform. Scroll down, main, paste it. And what was the CIDR range here? 10.0.1.0/24 and /16. Okay, right. Let's leave it as it is itself only. So once the subnet table has been created, what's next? We are going to create one route table, guys. Again, same here. Route table. I'm sorry. AWS Terraform. Just copy the route table here. The basic code will be there. Resources, route table, VPC ID. Yeah, this is the one I need. And then routes also we need. We also require the tags. Just come back to the Visual Studio Code, paste it, save it. Instead of example, why it is showing error? Okay, close the block, save it. Instead of example, I'll give public route table hyphen Terraform. Save it. I'm going to give the same name for my tags also. So meanwhile, instead of VPC example, my VPC name is different, VPC hyphen Terraform. Copy this and then paste it under example. Save it. So route blocks, I want this to go via internet 0.0.0/0. Save it. Gateway ID AWS underscore internet gateway. What was my gateway, guys? Internet gateway, here it is, internet gateway hyphen Terraform. Copy and then paste it here. Save it. So once this part is done, we are also supposed to create tags. Tags equals to set brackets open and close, enter. Name equals to double quotes. Along with the name, we should also give service. I know this, that's why I'm giving. If you also do the practice, then you will be able to understand it very clearly, guys. Just copy and then at the name, paste it, service Terraform. It's okay even if you're not giving the service name, but still it's going to take the tag as public rt hyphen terra. But we are also supposed to create one more thing under this route table itself only, which is route table association, guys. If you come back here to your AWS, come back to the VPC. If you go to the route tables, under route tables, you are going to find something called route table association. See, subnet association. So for this route table, you are going to attach this subnet. So whatever routes were there for this route table, those routes were accessible by this subnet itself. So that is something called subnet association. Right, the same thing, come back here and do the subnet association properly. Just go back here and then subnet association Terraform. Everything is documented. If you're able to read, each and everything is documented itself only. Just copy this and then paste it. Save it. So instead of A, I'll give public route table association hyphen Terra. Great. Just save it. Now, next what? We are going to create security groups now. Go back to the documentation again. Enter. Go through the documentation. In security groups, we do have two things, guys. One is inbound and outbound rule. Don't get confused. Here in the documentation, they are going to mention this as ingress and then egress rules, right? Ingress means inbound and then egress means outbound traffic. Got it? So this is actually the security group, resource and then AWS security group, resource TLS IPv4. Okay, we also need these values, but CIDR IPv4 and then IP protocol was not required. From port and then to port and then protocol is required. So if we go down to the arguments, we can find here actually. Okay, no worries. First, what we'll do is we'll create the block step by step. Just copy this first. Come back here, paste it. Allow TLS is fine, or else we'll keep allow all. Save it. Name also allow all. Save it. Instead of main VPC ID, what was my VPC ID here? I have to copy the VPC name here, paste it and then save it. Okay, once this part is done, just give ingress, guys. Like it's open and close. Here under ingress, see, copy this value, CIDR IPv4 from port to port. I'm going to give all traffic for both inbound and outbound. So CIDR IPv4 is not required. IP protocol is also not required. Protocol is required instead of IP protocol. Okay, from port 0 to port is also 0. Protocol type not TCP. Here you are supposed to give -1 and then CIDR block. CIDR underscore block equals to, you should pass this in a list, guys. We are passing it to internet, right? So 0.0.0.0 slash 0. Just save it. CIDR, it's blocks, not blocks. And then save it. Along with the ingress, we also required egress, which is outbound. Just paste it here and instead of ingress, change this to egress. Save it. Everything is same from port to port protocol and then to the internets 0.0.0 slash 0. At last, make sure that you're giving the somewhere it is wrong. Security groups, the block is starting here and it's not ending. Okay, control S. Now everything is fine. So here after this you can pass the tags actually. Save it, come back to the documentation. Where are tags? Here it is. Copy, save it, allow, all, and then control S. Great, guys. We have developed each and everything right from the top to bottom. So first we have created a provider block, and then resource block for VPC, and then this is the VPC name, and CIDR block for the VPC is 0.10.0.0/16, and DNS host name is true. These were tags, and again for the AWS Internet Gateway, the name was Internet Gateway hyphen Terraform, and we have given the VPC name here properly for each and everywhere. If you watch carefully, IZW Terraform ID. So there is a mistake here. See, uh, this was subnet, right? Subnet ID AWS underscore subnet. What was the subnet name here? If you go up, resource internet gateway subnet. My subnet name is public hyphen subnet hyphen Terraform. Just copy this, scroll down, paste it here, save it, and route table ID. My route table ID is mm, public route table. Yeah, this is the one. Copy, save it. Okay, done. Let's go and test this, guys, whether if it is deploying or not. Once after deploying, if everything goes good, then after that we are going to jump onto a topic called data source. So I'll just simply give Terraform init, which means we are initializing the Terraform here. See, just because of the provider block you have entered here, if you watch carefully, just because of the provider block, it is downloading the AWS plugin, and it's going to install this version 5.7.0. Okay, it has been successfully initialized. Terraform FMT, Terraform validate, Terraform plan, Terraform apply, enter. See, it says six to add. If you wanted to watch what were the six to add, AWS Internet Gateway, AWS route tables. See the hash here, guys. If you're watching hash here, then that's the resource it is going to deploy. And if you're destroying something, you are going to see some minus symbols here in the red color. Okay, so Internet Gateway, and then route table. Tags also you can check: route table association, security group, and then subnets, public subnets, and then VPC. We cannot depend on this dry checks itself. Sometime whenever you run Terraform plan, it's still going to give a green signal, but when you apply, you are going to see some issues, guys. So we cannot depend completely on the dry checks itself only. So that is the reason why you are not supposed to give hyphen hyphen auto approve at any cost in the real time. This is my local environment, right? So I can just give hyphen hyphen auto approve. Even if you're practicing in your local, you can still give, but in real time try to avoid that. Accidentally also don't give that hyphen hyphen auto hyphen approve, because once it has been started you cannot abort it. Actually, if you even if you give the control C, it's still going to throw an error: resource has been already been deploying and corruption might occur. So you're going to get such kind of errors. So we have successfully deployed each and everything here. Apply complete, resource 6 added. Okay, if you come back to the console, I'll just close this. Let's check only VPC one. Let's not check everything and waste the time. Go to the VPC. We'll check along with the tags and everything. Refresh. Okay, VPC Terraform. Come back to the tags. Okay, VPC Terraform. What were the subnets associated with VPC? CIDR was 0.0.0/16. Here you can able to see the subnet. See, Terraform public subnet, route table public, and then Internet Gateway Terraform. Fantastic. Now let's jump on to a different topic called data sources, guys. Data sources is very very important. For example, I'll show you in a very simple way. um, Just click on new. For example, watch carefully. There is a VPC here. Else I'll show you here itself only. Then you'll be understanding. See, there is a VPC here, and there is an internet gateway here. Just copy this. Rename. Guys, listen this carefully. This is very important. You're not going to do this frequently in the real time, but sometimes you are going to get this kind of activities. Watch carefully. Data source. What exactly is data source means? You have created one VPC here, guys, right? And the name was VPC hyphen Terraform, and the CIDR block was 0.0.0/16, and you have enabled DNS as hostname as true. Okay, and then after that you are going to create one internet gateway, and you want to attach this internet gateway to this VPC which you have created from the Terraform. Okay, this is super fine, good. But what if someone, one of your friend or one of your developer, has created a VPC manually here, not from the Terraform? Your friend or your developer, one of them has created one VPC here, and how you are going to attach this internet gateway to that VPC which was created manually? You are going to achieve that with the help of data sources only, right? So what I'll do is, to avoid the confusion, first I'm going to close this Visual Studio Code, and also I'll come back from this folder and I'm going to create one new folder, guys, else you will get confused. I'll name this as data source. Guys, whatever I'm showing, do the practicals please. And then I'll close this PowerShell also. See, I'm in data source folder now. I closed each and everything. Right click, open terminal. So I'll just simply enter code dot. It's going to take me to the Visual Studio Code. So before starting or before checking what exactly is data sources practically, let's go and create one VPC manually. And just come here, VPC only. I'll name this as data hyphen source. Scroll down. 10.0.0.0/24 is fine. Okay, we'll give this 10.0.0.0/16. Scroll down. Tendency, default name, and then tag is also data source itself only. See, guys, I'm not deploying this from Terraform. I i have created this from, I have created this manually from the console itself, right? Terraform is not going to capture this state, whatever is there just now we have created manually. Terraform is not going to capture this state, guys, because we have not deployed this from the Terraform, we did it manually. Now my task is, I wanted to create one internet gateway. So that internet gateway should go and attach to my VPC which was created manually. So how can I do that? Just create one file here, name this as data hyphen dot tf, enter. Simply come to the Google. Before doing this, we are supposed to let know Terraform that, see, there is a data source in the AWS console. You should go and communicate with that VPC first, and then attach whatever resource I am deploying to that particular VPC. So for that, we are supposed to come back to the documentation again, come back here, simply enter data source VPC Terraform, enter. Just open this. You are going to see the initial, yeah, this is the one. See, variable, no, variable is not required. Data source underscore VPC, and then selected means you are supposed to enter your VPC name, guys, or whatever service you wanted to attach, you are supposed to enter the VPC name first. So just copy this. I'll just copy this, come back here, paste it, save it. So selected means you are supposed to enter your VPC ID which was created manually, right? What was the VPC ID of that? It's data source. Copy this and then paste it here, save it, save it. Instead of ID, var.vpc ID, double quotes open and close, you should pass it as a string actually. Just come back here, what was the VPC ID? Copy this, paste it, save it. Now what do you want to create? I wanted to create one internet gateway. That internet gateway supposed to attach to the VPC. Got it? Just copy this, paste it instead of data, or else I'll do one thing, I'll show you directly from the document itself only, so you'll be understanding. Internet gateway Terraform, enter, open this, just copy the basic one, this basic one is enough, just copy it, paste it, save it. What was your internet gateway you wanted to give? I wanted to give this as an um, data source hyphen IZW. I'll give the same tag, just copy and then paste it. So what was the VPC ID here? VPC ID AWS underscore VPC from AWS VPC. What was your VPC name? My VPC name is data hyphen source. Just copy this and then paste it. This is ID. Save it. But before this, you are supposed to enter something called data.aws underscore VPC dot data source dot ID, right? So tags was data hyphen and then everything is fine. Control S. Let's come back here and first check. There were no internet gateways on this VPC ID, right? Just copy this, come to the internet gateway, paste it here, enter. No, see, nothing was there. No match found. Just come back here, Terraform init. Okay, Terraform plan. I just want to check whether if it is working as expected or not. Guys, again on a soft note, don't take me wrong. Please don't ignore the practicals. Whatever you're seeing is not that easy to practice. Internet gateway dot data source dot IZW will be created. Okay, fantastic. See here, plus resource. Okay, great. I'll just give Terraform apply hyphen auto. Let's not give auto approve, just give apply and then let's go with the prompt. Yes. Okay, enter the value. Yes. Okay, apply has been complete. So if you come back to the VPC and if you refresh here, see the internet gateway has been attached to this VPC successfully. This is how you have to use the data sources, guys. When going to the Terraform modules, you will be understanding it very, very clearly. So if you're not doing the practicals now, when going to the Terraform modules, you will not be understanding the flow actually. Right? So make sure that you're doing the practicals of it. Now let's end up with the last topic, which is Terraform data sources along with the remote state, guys. I will explain the plan now, then you'll be understanding each and everything. This is my base infrastructure actually, right? I'm drawing with the mouse, please try to understand. And here I do have EC2, I do have route tables, I do have internet gateway, I do have public subnets, and then I do have some XYZ resources here. I'm going to clone this, guys. Now watch carefully. I'm going to clone this now and I'm going to call this as base infrastructure, and also I'm going to store all this S3, I mean all this state file in the S3 backend, right? And again, I'm not going to create EC2 here. I'm going to take a new project and I'm going to create EC2 there. But here, if you create directly EC2, will it work? No, correct? Because this EC2 have some dependencies which were VPC, which were key pair, and then subnet, and then security groups, and then all these things. Some dependencies were there. So in this project, I'm not going to create any kind of networking part, but there is some S3 backend here, right? So whatever base infra is there, all state file will be stored in this S3 itself only. So with the help of this S3 backend, I'm going to create this EC2 instance, and also finally I'm going to create one S3 backend for this also. Finally, we are going to merge this to S3 backends, guys. This is my actual task now. This is actually a real-time task, so make sure that you're watching very carefully. So let's come back here and then again this has been deployed, right? Make sure that you're destroying. Enter. Sorry, Terraform destroy. Enter. The previous one also I forgot to destroy, but you guys don't forget to destroy. Once after the work is done, immediately destroy. I'll destroy after the session has been completed. Give yes. See all red color marks, minus, 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 and then destroyed. Okay, fantastic. It has been destroyed successfully. I'll just close this, which is not required. Um, I'll also gonna close this just to make you avoid the confusion. Okay, here I'm going to take, no, I'll not take anything. Come back to the browser. I'll just go to my GitHub repositories. I'll just clone this single instance repo. Just copy. Guys, don't worry, we do have variables, and then we do have tf-vars, and we do have outputs here. Don't just worry. Tomorrow we are going to discuss about this variables, tf-vars, and everything. But today I wanted to show you how you can use data sources with remote backend actually, or remote state. So I'll just come back here to the folder anywhere. I'll just create one folder here. I'll just give us task. Just open. I'll open in terminal. I'll also close this, which is not required. Git clone ls cd terraform single instance ls-al. No, ls-al will not work, so give ls only. Okay, I'll just simply give code dot. Here I cannot use rmf and rf, so this file is not required, this file is not required, this file is also not required, packer files are also not required. I'll delete each and everything. Just follow whatever I'm showing now. If you do not understand this variable.tf or tf-vars, just ignore, guys, but understand the gist of this data source with the remote state. Well, this is very very important. For example, this is main.tf. See how many resources were there here. I'm going to remove all these EC2 resources. This is not really required. Just close it, save it, and also this AMI not required. Save this. Can anyone tell me in the comment section what exactly is this? I'll show you something now. See this mark before S. If you watch my shell script session, then you'll be understanding this, specifically this symbol. Put it in the comment section if you know that. I'll just remove this. This is not required. Control save. Also, we don't require access key and then secret key, guys. I'll also remove this. However, we are going to pass from the CLI itself only, so we don't require. Once you are removing here, and then also make sure that you're supposed to remove under the variables also. So I'll just comment out this. Here also I'm not going to remove. I'll just comment this out. Save it. And default VPC, okay, internet gateway, AWS subnet 1 public, subnet 2 public, subnet 3 public, Terraform public, AWS route tables, okay, subnet 3 public, 2 public, 1, okay, security groups, and then route tables, and then association. If you come to the Terraform vars, okay, I'll also comment this out. AWS region, cider, public subnet, private subnet I don't want, I'll just comment this out. Public subnet, and here also private subnet is there. Comment this out. Main route table, key name, my key name is not that. Paste it here. Save it. Environment dev, leave it as it is. If you go to the variables, AWS region, AMI, cider block, public subnet, there will be some private subnets actually. If you wanted to learn and understand this code, please spend some time and read it, guys. You will be understanding everything. Nothing here, see, everything is interlinked. Region equal to, I've not given the region directly, just simply I'm calling it as a variable, because in real time you'll be working under some huge or large environments, so it's not good decision to give everything in the single main.tf itself only. So we are going to call each and everything as a variable. See, var dot AWS underscore region. If you go to the variables, variable AWS underscore region, and I'm not going to give the meta value here. I'm going to pass that meta value under TFRs. Region was US-East 1. Okay, so main.tf, everything has been cleared. Okay, so I'll just come back here again. I'm going to add one remote backend. I want the state file actually, backend type. Scroll down, copy this, come back here under main.tf, under provider.tf, save it. What was my bucket name? Let's go back to the S3. I'll just close this. This is not required. S3. I do have one bucket, I think. Cloud Vishwakarma. Okay, I'll create one new bucket. So I can Control C, scroll down, and then create bucket. The name should be unique, guys. So that's why I have mentioned all the name here. So this is my bucket. Okay, this is my bucket name. I'll just come back and save it. So key, I want this to name as base hyphen infra dot tf state. Save it, and the region is US hyphen east hyphen 1. Fantastic. Terraform.tfrs, everything is fine. Subnet, private subnet, key name SecOps. Okay, let's go to the PowerShell. Let's run Terraform init. Terraform fmt plan. Sorry. Okay, let's not validate. Let's enter this. It's not going to work, I think. Okay, let's go and check. Internet gateway, route tables, security groups, subnets, three public subnets, and then VPC. Okay, nice. Terraform, apply. Enter. Give the value as yes. EC2 VPC error, create VPC HTTP response status code API VPC. The maximum number of, oh, seriously? Okay, I'll do one thing. I do have, how many VPCs were there? Okay, data resource VPC, I'll delete. It's not required actually. I'll also, the first folder which we have created, not the data source, task, no, not this one. Here also I'll log in and then I'll destroy. Okay, now let's come back here and check. Now let's come back here. Terraform apply. Give the value as yes. It's creating. Okay. Okay. Fantastic. Terraform state list. It's going to give us what and all resource has been created. Okay. Three subnets, one security group, route table association, route table, and then okay. Fantastic. Again, if you go back, so there should be no state file here because it will be already managed from the backend. I'll close this, guys. Not required. Go to the S3 bucket. Here is my S3 bucket. Mastering cloud. See here. This is my state file. Everything has been deployed successfully. Now watch carefully. I'm going to create one more folder here. In this folder, I'm not going to keep anything. I'll just keep only EC2 and then data sources. I'll tell you. Um, I'll name this as main task. Enter. Instead of PowerShell, I'm going to open this with Git Bash so that you'll not be confused between the before one and this. Code dot. Okay, new Visual Studio Code has been opened. I'm going to give ec2 dot tf. That's it. Save it and come back here to your repository. Control T, GitHub. Here I do have ec2 actually. Terraform single instance. Under main.tf, just copy this. Save it. Okay. Now I hope you understand what exactly I'm doing. In the before project, if you watch carefully, I do have each and everything whatever is required to deploy the EC2 instance like AWS, I mean VPC, Internet Gateway, subnets, three public subnets, and then route table. But from here, I haven't deployed the EC2 instance, right? But I just created another folder here which is called as main task. Here I'm not giving any networking components, but still I have given only EC2 alone. Will it's going to create? No, guys, because there were no EC2 components here to create. But how it's going to create? As I said in the before diagram, we are going to use the state file. See, we do have one state file here. So base infra.state file. We are going to use this state file with the help of data source, and then we are going to deploy this instance which is in the project 2. I mean this main task, right? Come back here. I'll just make sure that I'm escape. So I'll remove this AMI. This is not required. Let's do it from the first very carefully. Remove this hashtag, Control S, AMI ID. Come back to the instance EC2. Guys, I hope you're understanding what I'm doing now. I'll do one thing. Wait. I'll just draw the diagram again. I have deleted unnecessarily. See, before we have created one base infra, right? This is base infra. In this base infra, what and all were there? uh, AWS subnet is there, route table is there, security group was there, and then three public subnets, and then VPC. Everything is there. What all the EC2 components were there? Networking components all were there in this base infrastructure, and we also store this state file under remote backend. Correct? And here, do we created EC2 instance? No, we haven't created EC2 instance here. Now I have just created another project which is called as main task, if you remember. So from here, I'm going to create one EC2. How I'm going to create the EC2 now? Because there were no networking components to create the EC2. I'm going to use this state file, guys. or just before we have seen something with data sources. So using the data sources as a backend, we are going to create this EC2 instance, and also we are going to create one S3 bucket here just to store this EC2 state file. Got it? Just come back here again. Where are we at exactly? Um, okay, copying the AMI ID. Come back, launch instance, select Ubuntu, copy the AMI ID, come back here, paste it, save it. Availability zone USC-1A, instance type T2 micro. This key is not there. I deleted long back. So I just want to create the key again. Copy. This is my key. Come back here and then paste it. Save it. Subnet ID and then security groups. Here comes the very important step. Just create another file called data source. Data hyphen source hyphen backend.tf. Enter. Just come back to the previous file. You have created one data source, so you have closed it. Okay, no worries. Just come back here and then you will find it in the documentation. Just go back. Yeah, this is the one. See, data underscore AWS underscore VPC. Paste it. We need three resources. This is for VPC, and this is for security groups, and this is for subnets. AWS underscore VPC, which is selected. Selected means my VPC name I have to enter. So whenever you're deploying this EC2 instance, it's going to take the VPC values from the before state. See, before state means this. We have already deployed this. So let's go back. Let's go back here and enter VPC. Your VPC. My VPC name is Terraform AWS testing. Yeah, this is the one. Just copy. It should have three subnets if I'm not wrong. Go to the resource map. Yeah, see, one, two, three subnets. Great. This is the one. Come back to this project and enter the VPC name here. What was the ID of the VPC? Just call it under double quotes. Save it. Just come back here. AWS underscore VPC, Terraform AWS testing, ID equal to VPC, and then yeah, this is the VPC ID. Now, what was the second one, guys? What was the requirement here? One is subnet, and the other one is security group. Copy this VPC underscore AWS underscore VPC underscore security group. What was the security group name? Just copy this VPC ID, come back to the security groups, paste it, enter. Array, it's why it has taken here. Security groups, enter. So my security group name is hello all. Copy hello all. What was the ID of my security group? Is this. Give it under double quotes as a string. Save it. And what was the third one we required? I did a mistake, guys. I did a mistake here. Security group should be last. Here we are supposed to enter the subnet actually, not the security group. What was the subnet? What was the subnet name there? Scope. Go to the subnets. Take any one of the subnet. Terraform public subnet 1. I'll take this public subnet 1. Copy. Three subnets we have created, right? See, 1, 2, and then 3. I'm taking the first subnet and I'll copy the first subnet ID also. So this is my subnet name. Save it. Var.vpc. I'll just remove this. I'm going to call the ID under strings. Copy. Guys, please share it with your friends. Don't forget. Save. And also please do subscribe if anyone didn't subscribe. AWS underscore subnet Terraform public. Okay. Save this. Now do the changes very carefully, guys. Subnet underscore ID here. This is not the actual one. You are supposed to pass a argument called data and then come back to the data here. The very first one is subnet, right? Subnet underscore ID. Okay. So from here, copy it carefully. How I know all these? Do lot of practice. You will also know all these. You will also understand Terraform very well. Data dot AWS underscore subnet dot Terraform underscore public subnet hyphen one testing dot ID. Save it. VPC security group IDs. Okay. I'll also just okay from here I'll copy security group, right? So just copy this EC2, paste it. Data dot. Let's remove this and give how it works. Dot data underscore data dot AWS underscore security group dot hello wall dot ID. Save it. Public IP address true. Tags. Okay. Server one prod I cost center. Okay. Everything is fine. Right. Great. Let's go back to the CLI Terraform init. Should hopefully work. Okay. It should create one instance. Let's go back here and then why three instances were there? This is for Kubernetes. SecOps. Okay. Let's come back. See, there is an issue here. EC2.tf line 7 in resource AWS instance web 1. Data dot AWS underscore security group dot LOLD. Inappropriate value for attribute. Do we enter any wrong? Let's do one thing. Let's call it under dollar and then curly braces. It's closed. Dollar curly braces. Call this as list. Okay. Now run Terraform plan again. VPC security group IDs. Where was this yes came from? Inappropriate value for attribute. VPC security group IDs. Yeah, now it's working. Some indentation error is there. Okay. Terraform apply hyphen hyphen auto hyphen. No, let's not give this. Enter. Give the value as yes. Hopefully it should create one instance. Creating. Okay, it has been successfully created. Let's go back here, and if I refresh, see guys, I can able to see server 1 here successfully. Okay, great. If you come back to the S3, refresh, nothing will be there. Now I wanted to copy this current state. See, this is the current state, EC2. I wanted to copy this current state to my S3 bucket here. So I'll be having two state files in total. One is for the base infrastructure, another one is for the recent one. This is the current state. This is the one. So how can I do that? Come back here. I'll just come back here to the code. I'll just copy this. Copy, and then data source EC2, here only I'll paste it, save it. Instead of base infra.tf state, I'm going to give this as current state. Save it, just run it again. It's going to give the error because we have added the remote backend, right? So Terraform, run the init again. Give the value as yes. What it is saying, pre-existing state was found while migrating the previous local backend to the newly configured S3 backend. No existing state was found in the newly configured S3 backend. Do you want to copy this state to the new S3? Give the value as yes. Okay, Terraform has been successfully initiated. If you come back to the S3 and if you refresh, see, I do have two state files here. One is for the base infrastructure for this, and the other one is for my current state. This is the one. Got it? This is how they are going to maintain the state files, guys. When you're learning about the Terraform modules, you are going to see a lot of state files here, right? Please do practice, and also don't forget to subscribe to my channel, and please let your friends know that we have started DevSecOps series, guys. So many of the people, what they're saying is they are getting some good content here, and they wanted to, like, stay low, and they're not informing to anyone that our YouTube channel is there and we have started the DevSecOps. It's not good, guys. The more you share the knowledge, the more you grow, honestly. If you are being selfish at sharing your knowledge, then you will not grow, you will stay there itself only, right? So we'll see you in the tomorrow session. Don't ignore the practicals, just practice each and everything and post it on the LinkedIn. I'll be watching on it. Thank you so much, everyone. Bye bye, have a nice day.